Go. Hello, Mr. Ryan, are you right?
Yeah.
Yeah, okay. So we talk about linked list, okay? Linked list. How many type of linked list do we have? Linked list. You know the node?
Singly, doubly.
Yeah, singly, doubly, two. This is what? What's this? This is
Singly.
singly, right? And what's doubly? What's doubly?
It has a cycle.
It has a cycle, not quite. What's singly means single direction. What doubly?
Two direction.
No, this is still singly. The doubly is that it has another additional link from the current node linked to the previous. Okay? Okay? This is doubly. Okay? Yeah. So these are the data structure. This is the data structure to store the data, right? It's one kind of data structure. And how does it differ between the list? You know, normally we have a list, yeah? A equals list 1, 2, 3, 4. Okay? The list is quite simple, yeah? It holds the elements, right? And then these elements are put one by one next to each other, right? So we can have this random access. If we want to retrieve the third number, we can just do A what? The first index, the first number is A0, right? The third number is what? Anyone? How can I retrieve this number?
Head on next.
This is the list. A what? How many? A?
4.
4. How many? What's this number? A what? If I put one number here, what's this?
3. 2.
2, yeah, because it starts with 0. Like A0, A1, A2, A3, okay? Make sense? Good job. Okay, so now the thing list, we're talking about the thing list here. Okay, so we have head here. And we point to the next. We point to the next. Okay, so this is 1, 2, 3, 4. Right? So if we want to retrieve the number in the third node, we can't just do this like the list. Right? We have to travel from the head to next, the next, right? So the traveling time is linear, right? It's all what? If the
N.
right? The previous one, the A dot list, yeah, A dot list 1, 2, 3. We want to get these, the time complex list of 1, yeah, because we know this address of the A, and we can base on the type of the element, we can calculate the address of any numbers in the array, right? And then because the array is quite simple, that we don't store any additional overhead, right? But for this one, we also need to store one more thing, which is the pointer points to the next, right? So if you look, there are 4 numbers here, 1, 2, 3, 4. We need to store 8 units of thing, because look, these 4 numbers, and each node will also have this pointer to the next one. So yeah, do you get it? But for this one, for the linked list, the advantage of using linked list is that it does not have to be continuous, right? So these and these nodes could be separate apart in memory. But for this one, the linked list, for the list, it has to be continuous. So you know the computer RAM is limited, the RAM, yeah, like a table, yeah. If a table is limited, so if I want to store like sometimes I want to store 1 million data, right? For example, if this thing, like 1,000 elements, right? And I want to allocate, sometimes I cannot find a continuous space for the 100 elements, right? But for the linked list, I can, because this linked list can be separated in, the nodes, it could be separated in different parts of the table, yeah, of the RAM, right? So I can do it. Okay, this is the one difference. Okay, so let's do a very good easy problem, which is to find the length of a linked list, right? So let's say I have a head. I want to find the length of the linked list. How can we do this? The length of the linked list, head. How can we do this? Any idea? You want to travel
While head.
while head, okay? While head is not the end, yeah? What do we do? But before that, we need to declare a number, right? An answer
On equals 0.
and y ahead. What? What's next?
Return
Return?
answer.
Where do you put the return? Y ahead what? What do we do with the y ahead? Come on, you can do it.
Return answer
Uh-huh.
plus equals 1.
Okay, and then what should we do with the head? What should we do with the head? Moving to the next.
Head dot next.
Head equals what?
Head dot next.
Okay,
Return answer.
we're done. What's the time complexity for this one?
ON.
The n is the number of nodes in the linked list. We're done. This is iterative, right? Iterative. We can also do it in recursion. So how can we solve this problem recursion? Look, this is head, right? This is head. So the entire linked list, the length of the entire linked list is what? Is the thing. This is what? This is what? This whole thing here is what? Start here. What's this? What's this node?
Head dot next.
Head dot next. We're done. So look, the linked list, the length of the entire linked list is one node here, plus the nodes. I'm not sure how many nodes are here, but I know it's head dot next. So I can use the recursion to call itself to solve the problem, a smaller problem, right? Okay, so define the terminal condition is that when the node is empty, then with the return, yeah. Length head, and then what should we do? What should we do? If not head, if head is none or not head, okay, then we return none, 0, okay? And then otherwise we return what?
Return
Return what? Yeah.
head.
No. How many nodes here?
Head dot next.
Every-
1 plus
Yeah.
length dot head dot next.
Okay, we're done. Okay. Yeah, recursion. This is recursion. Calling itself. This calling itself, right? Calling itself. One node. Because look, we want to calculate how many nodes are in entire linked list. It's equals to one node here. I know it's one node here. And then use head dot next is this sublink, yeah, this linked list, and I call itself to solve this and then return it. Yeah. Make sense?
Yeah.
Yeah, clear? So because this recursion, yeah, recursion has the one problem, it's called stack overflow. Stack overflow. Because every time we want to call a recursion calling itself, we need to push the address of the caller, and then we need to push the parameters in the stack. Stack is a fixed size in computer, right? In the computer. So once the number of elements exceeds the stack size, then you will call stack overflow, right? If the linked list has a million elements, it probably will have this problem, right? So the best approach would be the previous one, which is iterative. Okay, for this recursion, we can write it in one line, right? Look, return 1 plus then head dot next. If what? If head else 0, yeah, we can just remove this, yeah. Return.
Yeah.
Look, one line. Return 1 plus then head dot next, right? Alright.
Yeah. Let's get moving.
And else 0, okay?
Let's get moving.
Okay, so yeah, that will be it today. Bye bye.
Bye.
Bye bye.